Welcome to the DX Today podcast, where you get facts, not hype. And today, we're diving deep into the facts that are really shaping the future of your career. For the last, 2 or 3 years, the entire conversation around AI has been about novelty. Look what this chatbot can do.
Or the fear, is this thing going to take my job?
Exactly. But today, for you, our listener, we're skipping all that hype. We're going to analyze the sources you've provided to focus on the reality of 2026, which a lot of analysts are starting to call the AI reckoning.
That's the perfect term for it. And our mission today is really laser focused. It's to pinpoint the career paths that are not just valuable now, but sustainable through the end of the decade.
Because the ground is shifting so fast.
It's already shifted. I mean, the industry has moved past the point where a generic data scientist title or some basic machine learning skills are enough. Capital, investment money, it's now flowing almost exclusively into solutions that solve the core problems of running AI.
And you call these the frictions.
The frictions. Things like reliability, governance, the physical demands of robotics, and maybe most importantly, the actual cost of running these systems at scale.
So we're looking for the strategic lanes where the barriers to entry are high enough that your skills won't be automated or commoditized away in 6 months. What's the core idea we need to start with?
The key takeaway is specialization, but it's specialization focused on solving complexity. We're seeing this intense investment across 4 main pillars, and these are really the roadmap for your career. The architects of autonomy, the guardians of trust, the frontiers of science, and finally, the orchestrators.
Okay, that's a fantastic structure.
Yeah, if you're aligning your skills for the late 2020s, you need to be building deep expertise in one of these 4 areas.
Perfect. So let's map this out for you. We'll start with the macroeconomic picture, this great reckoning. Then we'll get into the engineering, the shift to what's called agentic AI. After that, the mandatory rise of governance roles, the auditors are coming, and finally, we'll look at how AI meets the physical world and what it all means for management. All right, let's unpack this. The sources keep using this term, the Great Reckoning of 2026. It sounds a little dramatic. What does it actually look like on the ground for businesses?
Well, it is dramatic in a way. It's the ultimate moment of truth for enterprise AI. The reckoning is just this transition from a hype cycle we saw from, say, 2023 to 2025.
Right, where potential and novelty were enough.
Exactly. That drove valuations. Now we're in a maturation phase where rigorous, quantifiable performance is the only thing that matters. Companies are now demanding operational resilience and a demonstrable return on investment, ROI from every single AI system they deploy.
So we're past the phase where a big company invests millions just to have a cool-sounding AI project to put in their annual report.
Oh, completely. The sources are very specific about this. They call it the end of pilot purgatory. Think of all those proof-of-concept projects that looked great in a controlled sandbox.
But never made it out into the real world.
They never scaled across the enterprise. In this new era, that failure to scale is basically a capital offense. The focus has pivoted entirely to what the sources are calling inference economics.
That's a great term. If training was the big cost story of 2023, then inference economics is the defining cost of 2026. Break that down for us.
Sure. So inference is the moment of usage. It's when a live, trained model actually generates a response for a user.
So every time I ask ChatGPT a question, it's one inference.
Precisely. And when an application is serving millions of those requests every single day, from customer service chats to code generation, the cost of each one becomes the primary economic bottleneck. It's the latency, the memory it uses, the GPU hours it burns.
So the game has changed. It's not just about who could build the smartest model anymore.
Not at all. The new competitive edge is the ability to deploy intelligent systems reliably, safely, and most importantly, orders of magnitude more cost-effectively than your rivals.
When you say cost-effectively, what kind of scale are we talking about here? How big is the financial impact?
It's astronomical. For the big cloud providers and large tech companies, even a tiny single-digit percentage reduction in latency or memory use can directly translate into tens or even hundreds of millions of dollars in annual savings on their compute bill.
Wow. So it's not an engineering problem anymore. It's a C-suite profit and loss problem.
It's a core business function now.
That makes sense. But speaking of costs, the sources also paint a really complex picture about AI and jobs. The simple narrative is just, displacement. But the reality seems much more turbulent, more paradoxical.
It is a profound structural transformation, not a simple replacement. The World Economic Forum data is pretty clear on this. They forecast a net increase of 78 million jobs by 2030.
Net increase.
Yes. driven by the creation of about 170 million new roles, which more than offsets the 92 million that are displaced. But, and this is the crucial point, the titles of these new roles are highly specialized. They're often completely unrecognizable to someone from, say, 2020.
Okay, so let's dig into those paradoxes you mentioned. The first one is this tension between productivity and real-world trade-offs.
Right. Despite the promises of these incredible productivity gains, organizations are hitting some harsh realities that limit just adopting everything at once. Yes, AI makes some tasks faster, but it also introduces brand new costs and risks.
Like the energy consumption.
That's a huge one. Soaring energy demands are in direct conflict with corporate net zero and sustainability goals. We'll get more into that later. But there's also just market anxiety. The AI bubble fear is forcing companies to scrutinize their headcount with a fine-tooth comb. They're prioritizing roles that deliver immediate, measurable value.
Which means they're cutting.
They're cutting the speculative R&D teams. Or the basic data science functions that just haven't shown a clear path to ROI. The filter is getting very, very fine.
So companies are getting brutally efficient. And that brings us to the second paradox. Technical automation versus human demand.
This is a fascinating one. AI is truly phenomenal at automating repetitive technical tasks. Generating boilerplate code, organizing data, drafting reports.
The grunt work.
A lot of it, yes. But what the sources show is that the demand for uniquely human skills that require complex judgment and synthesis, has actually intensified. It hasn't decreased at all.
And what skills are we talking about? What's surviving this automation wave?
Analytical thinking is still number one. A full 70% of companies view it as absolutely essential. After that, you see things like resilience, flexibility, and leadership. The market is increasingly rewarding what the sources call super agency.
Super agency. I like that. It sounds less like a buzzword and more like a specific capability. What does it actually look like in practice?
Super agency describes a professional who can wield AI not just as a tool to type faster, but as a strategic partner, as a teammate almost. They use it to solve novel, complex problems that cut across different business units.
So it's not about just coding faster.
Not at all. It's about having the critical judgment to define the right problem for the AI to solve in the first place, and then orchestrating the entire solution using both human creativity and the efficiency of what you could call your digital workers.
Can you give us a quick example, the difference between a basic technical task and a super agency decision?
Certainly. So a traditional technical role might focus on, say, optimizing the code for a specific forecast model. A professional with super agency would step back and ask a different question. They'd ask, okay, given our Q3 revenue targets, should our AI resources be building a more accurate customer churn model? Or should we prioritize an agent that optimizes our supply chain logistics, because that's the bigger friction to growth right now?
It's the what and the why, not just the how.
Exactly. And that level of strategic complexity, that can't be automated away.
That sets the stage perfectly. Now, let's look at this globally, because the sources are adamant that these opportunities aren't the same everywhere. It's very dependent on your region.
It is. This is the global talent map of 2026. If you look at the US and Europe, the tech sector is pretty mature, and the regulators are flexing their muscles.
Right, with things like the EU AI Act.
That's the biggest driver, and it has pushed the career focus heavily toward roles in what we're calling Pillar 2. Governance, compliance, deep tech optimization, and risk mitigation. The fines for non-compliance are massive, so the demand for these roles is non-negotiable.
But Asia-Pacific is a totally different story, isn't it?
A completely different dynamic. In APAC, Hong Kong, Japan, Singapore, they're facing severe talent scarcity combined with an aging population. We're seeing figures like 62% of employers in Hong Kong citing talent shortage as their number one challenge.
So for them, AI isn't about replacing workers.
It's often about filling roles that they simply cannot fill with the available human workforce. It's automation as a necessity to keep the lights on, not just as a cost-cutting measure.
I mean, what kind of roles does that create?
Huge demand for what are called AI integrators. These are professionals who can rapidly deploy off-the-shelf AI solutions into legacy business systems. And there's also a big demand for corporate learning leaders who can run massive upskilling programs to shift their existing staff into these new roles.
And you also mentioned an infrastructure boom.
Yeah, that's happening across India and Southeast Asia. Countries are building their own sovereign compute capacity, so that translates directly into jobs for AI infrastructure engineers, the industrial plumbers we'll talk about, in those specific regions.
Okay, this confirms it. Specialization and knowing your regional context are everything. So let's formally reintroduce those 4 pillars, the career havens, that are protected by these high barriers to entry.
Okay, Pillar 1 is the architects of autonomy. These are your core engineering roles, building agentic AI, running the infrastructure, and focusing on radical efficiency. They solve the friction of cost and reliability.
Got it.
Pillar 2, the guardians of trust. These are the non-negotiable roles driven by regulation governance, ethics, algorithmic auditing. They solve the friction of legal and social risk.
Makes sense.
Pillar 3 is the frontiers of science. This is where AI leaves the screen and enters the physical world. Think robotics, generative biology, new computer chips. They're solving the friction of physical reality.
And the last one.
Pillar 4, the orchestrators. These are the management and product design roles. They focus on managing probability, designing how humans interact with AI, and leading these new hybrid teams. They solve the friction of collaboration and uncertainty.
That structure is incredibly helpful. Let's start right at the foundation. Engineering the new core, pillar 1. All right, engineering the core. The sources all seem to agree on one huge technical shift that is defining this new landscape. And that's the move from passive tools to what you called agentic AI.
Yes, and this is where that generic data scientist title really starts to lose its meaning. The shift is architectural. We're moving away from a simple, static system where you type a query and you get a single text response, the standard chatbot,
Right.
to agentic AI. These are systems capable of high-level reasoning. They can plan multi-step actions and then actually execute those complex workflows with only minimal high-level human oversight. The market is desperate for engineers who can build this functional super agency.
So if the agentic AI engineer isn't just training models anymore, what's their day-to-day actually focused on?
They're focused on system behavior, on cognitive architecture, and, crucially, on robustness. By 2026, basic RAG retrieval augmented generation, where a model just pulls info from a document, is table stakes. It's commoditized. The agentic engineer has to master advanced RAG and what's called strategic retrieval.
Okay, advanced RAG. How is that different from the basic RAG systems we were all building a couple years ago?
It's all about precision and pre-processing. Basic RAG just kind of dumps your query into the LLM and hopes for the best. Advanced RAG involves much more sophisticated steps. First, determining when an agent even needs to look for external information.
Ah, so it doesn't just search for everything all the time.
Exactly. Then it has to formulate that retrieval query intelligently to minimize noise and irrelevant context. And then, this is the critical part, it verifies the integrity and relevance of the data it got back before the agent is allowed to use it to generate an answer or take an action.
That sounds like you're building a sophisticated prefrontal cortex for the AI.
That's a great way to put it. And that thinking needs to be connected to action. The sources emphasize that these agents only become truly powerful when they can actually do things, which means the engineer has to master tool use and robust API integration.
So connecting the AI to other software.
Correct. The engineer designs safe, reliable interfaces that let an agent do things like query an internal SQL database, run a Python script, or interact with external systems like a flight booking API.
But the real challenge there isn't just making the connection. It's managing all the ways it can fail in the real world, right?
Absolutely. Safety and reliability are what define this role. The engineer has to manage all the real-world constraints. Things like API rate limits, secure authentication, and most importantly, designing sophisticated fallbacks.
Give me a concrete example of a fallback.
Okay, imagine an agent is tasked with booking your travel. It needs to use 3 different APIs. One for the flight, one for the hotel, one for the car. What happens if the hotel API just times out?
Right. It can't just stop. Or worse, pretend it worked.
Exactly. The system can't crash, and it absolutely cannot hallucinate that the hotel was booked. The agentic engineer has to design the agent to handle that failure gracefully. Maybe it retries the call a few times. Maybe it escalates the error to the human user saying, "Hey, I couldn't book the hotel. Can you help?" This failure management is the difference between a cool demo and an industrial strength application.
That's where the real value is.
Yeah.
And this engineer also designs systems where multiple AIs work together, right?
Yes, that's multi-agent orchestration. They're designing the system's whole cognitive architecture. That includes things like complex memory systems, balancing the agent's short-term context with the long-term memory so it can remember your preferences over weeks. And orchestration is like building a digital team. One generator agent writes the code, and a separate critic agent reviews it for security flaws before it ever gets deployed.
Okay, that's system design. Now let's talk pure efficiency. The second role in this pillar is the inference optimization engineer. You said this is one of the most financially valuable roles out there.
This is pure profit optimization, straight to the bottom line. As the industry's costs shift from training models to actually using them, inference companies are spending fortunes running these models live 347. An engineer who can shave off 50 milliseconds of latency or reduce the memory footprint by just 10%
Is saving them millions of dollars.
millions in annual cloud bills for companies at the scale of a Tesla or a Microsoft. This role is a direct lever on the company's balance sheet.
So what are the specific, deep-in-the-weeds techniques these engineers are using to squeeze out that performance?
They are living at the intersection of hardware and software. They're masters of compromise. The three core techniques the sources highlight are quantization and pruning, speculative decoding, and knowledge distillation.
Let's start with quantization. That's about changing the math inside the model itself, isn't it?
It is. A standard model might use 16-bit floating point numbers for all its parameters. These engineers figure out how to convert those down to a lower precision, like 8-bit or even 4-bit integers. Quantization is reducing that precision. Pruning is literally cutting out unnecessary connections in the neural network.
And the result is a much smaller model.
Dramatically smaller. It shrinks the memory footprint, which lets these powerful models run faster on cheaper, more available hardware, or even on your phone.
That's a huge deal for lowering costs.
Oh.
What about speculative decoding? That sounds clever.
It's an ingenious trick. Normally, an LLM generates words one by one, which is slow. With speculative decoding, you use a tiny, super-fast draft model to predict a whole chunk of text. Then the big, powerful verifier model just has to check that draft instead of generating it from scratch.
So it's a draft and review process, but happening at machine speed.
Exactly. And that loop can double or even triple the inference speed because the big, expensive model is spending its time validating, not generating.
Incredible. And the last one, knowledge distillation.
Knowledge distillation is all about the edge, about getting AI onto devices. You train a much smaller, resource-efficient student model to perfectly mimic the behavior of a giant, resource-hungry teacher model. Then you can deploy that little student model on a phone, a factory sensor, or a drone, places with limited battery and processing power.
These skills sound incredibly deep and specialized. This isn't something you learn in a weekend boot camp.
Not at all. This role requires a unique blend. You need deep knowledge of computer architecture, systems programming. We're talking C++, Fun, CUDA, Python, and a deep understanding of frameworks like PyTorch. And crucially, the sources say this role is highly resistant to automation because you're dealing with the physical constraints of silicon and electricity. You can't just prompt a model to make your hardware run faster.
All right, so we have the agent, which is the brain. We have optimization, which is the cost savings. The third leg of this stool in Pillar 1 is the AI infrastructure engineer.
These are the industrial plumbers of the AI factory. This is the evolution of DevOps and MLOps, but specialized in managing these massive, expensive compute clusters. Their whole world is the plumbing needed to get to 99.9% uptime and reliably feed data to thousands of GPUs at once. Their day-to-day is GPU operations.
What's unique about GPU operations compared to just standard cloud computing?
It's managing the very specific complexities of these huge GPU clusters. You need sophisticated scheduling with tools like Kubernetes to make sure these expensive resources aren't sitting idle. You have to manage severe thermal constraints. These things run incredibly hot.
Right.
And most importantly, you have to build fault-tolerant systems. A state-of-the-art training run might take weeks. If a single piece of hardware fails halfway through, you can't lose all that progress. The engineer has to build a system that survives that failure, checkpoints its progress, and resumes automatically.
This sounds like the perfect career path for an existing site reliability engineer or a Linux systems admin.
It's the most direct path. If that's your background, the next steps are to master Python, really understand GPU memory hierarchies, and become an expert in distributed file systems like Lustre or Ceph. You have to know how to feed the data to the GPUs fast enough so they're never starved.
So Pillar 1, the architects, is all about solving the friction of complexity, efficiency, and reliability. That handles the technical and financial risk. The next big friction is the legal one. That takes us right into Pillar 2.
Okay, we are definitely out of the Wild West days of AI. The sources couldn't be clearer. Governance isn't some optional philosophy club anymore. It's a hard, non-negotiable compliance requirement.
Absolutely, and it's being driven almost entirely by major regulatory frameworks, especially the EU AI Act. The era of just, moving fast and breaking things with AI is over for any large company that operates globally.
And that legal necessity has created a whole new high-paying job market. The main role here seems to be the AI governance officer. Yes, or sometimes just the AI officer. And it's important to understand how this role is different from, say, a chief compliance officer or the data protection officer, the DPO, that we got used to with GDPR.
How is it different?
A DPO is primarily focused on privacy and data collection. The AI officer's job is much broader and way more technical. They have to focus on the outcomes and the impact of the AI system itself.
So things like bias, safety, accuracy.
All of it, and making sure high-risk systems are interpretable. They operate at this intersection of legal, technical, and risk management, and they usually report directly to the board's risk committee or another senior leader.
The salaries we're seeing for these roles are significant. What are the high-stakes responsibilities that justify that?
Well, the biggest drivers come directly from the EU AI Act, which creates these new complex duties. First, they have to oversee what are called conformity assessments. Before any high-risk AI system, think credit scoring, recruitment software, medical diagnostics, before that can be sold in the EU, the AI officer has to manage this massive verification process.
It's like a full technical audit before you can even go to market.
It's a huge undertaking. And second, they're responsible for the crucial job of risk categorization. They have to decide if a new system is prohibited, high risk, limited risk, or minimal risk. And that single decision determines the entire level of regulatory scrutiny the company will face. The legal and financial implications are massive.
And I imagine their job isn't done once the system is launched.
Not at all. That's the third major responsibility: post-market monitoring. The AI officer has to set up technical systems to track how the AI is performing out in the real world. They need to make sure the model doesn't drift into unsafe or biased behavior over time as the data it sees changes.
They're the company's internal defense against model drift.
You could think of them that way, yes. And it explains the compensation. We saw data in the sources citing median salaries for these technical governance roles at over $221,000 in the tech sector.
And that's because the risk of getting it wrong is so high.
It's a direct reflection of the financial risk. Under the EU AI Act, the fines can go up to 7% of a company's global annual turnover. So companies don't see the AI officer as a cost. They see them as an essential insurance policy against a potentially catastrophic penalty.
Okay, so if the AI officer is the internal manager, the second key role here is the algorithmic auditor. This is the person who comes in from the outside to verify everything.
The algorithmic auditor is the independent verifier. They're the ones who truly open the black box, especially when the regulators come knocking. Their whole skill set is built on something called mechanistic interpretability.
Which means?
It's the ability to actually understand the internal workings of a neural network, the specific logic path as it's taking, its decision criteria. It's the opposite of just treating it like a magic input-output machine.
So what specific methods are they using to conduct these audits? How do they stress test a model's trustworthiness?
Well, they have a whole toolkit. One of the main ones is red teaming. This is where they actively simulate attacks. They try to trick the model into generating harmful content or get it to reveal sensitive training data. It's a proactive security test.
And what about finding those really deep systemic biases that might not be obvious on the surface?
For bias, they use counterfactual testing. A classic example would be taking a loan application model. They'll run a scenario, then change just one protected attribute, like the applicant's gender or postcode, while keeping all the financial data exactly the same.
And if the credit score changes?
Then you found a latent discriminatory bias that has to be fixed. It makes the cost of unfairness measurable and impossible to deny. It brings a scientific rigor to what used to be a philosophical debate.
It really does.
And finally, they do meticulous process auditing. They check to make sure the mandated human in the loop, that human reviewer for high-risk decisions, is actually influencing the outcome and not just being forced to rubber stamp whatever the AI says.
This sounds like a brand new profession that needs formal credentials. Are we seeing those emerge yet?
Oh, absolutely. The market is moving fast. The AIIA from ISACA, that's the Advanced in AI Auditor Cert, is becoming a standard. And even more so, the certified ISO IE 42001 lead auditor credential is becoming essential. That ISO standard is the global gold standard for validating a company's AI management system.
So these are basically becoming the CPA exams for the algorithmic age.
That's the perfect analogy. And it all points to a need for a totally new educational pipeline because you need this hybrid of legal, technical, and statistical skills.
And universities are starting to respond.
They are. We're seeing these specialized master's programs pop up that focus on what you could call hybrid fluency. Places like Northwestern with their technology, people, and policy program, or Duke with its bioethics and science policy program. They're specifically designed to train these new governance specialists. The era of keeping your lawyers, your ethicists, and your engineers in separate buildings is completely over.
All right, we've covered securing your career through compliance and through cost efficiency. Now let's shift to the high-risk, high-reward R&D space. This brings us to Pillar 3, the frontiers of science. This is where AI moves beyond the screen and starts interacting with the physical world, from bits to atoms.
This convergence is arguably the most radical and transformative area in the long run. It's all about taking the complex reasoning abilities of AI and applying them to physical processes. And we're seeing two main frontiers here, generative biology and robotics, and then entirely new kinds of computer chips.
Let's start with generative biology. The sources mentioned a fascinating workflow called lab in the loop.
Right, or LITL. So historically, AI was just used to analyze data that came out of experiments. With generative biology, the AI is now designing the experiments. LATL is the system that makes that happen.
How does it work?
It's a closed, automated loop. The AI proposes a complex scientific hypothesis, say, a new protein structure for a drug. Then, robotic systems in the wet lab immediately execute that experiment. The results from that physical test are then fed back to the model in real time, which allows it to refine its hypothesis for the very next run. It's active learning, but applied to physical reality.
So the AI is learning directly from what's happening in the real world, not just from a static data set.
Precisely. And this creates a need for a new type of scientist-engineer, someone who understands machine learning, but also understands automated liquid-handling robots and the underlying biology. The big pharma and biotech companies are hiring for these roles right now.
And why is this so important for the wider economy?
Because it promises to radically accelerate drug discovery and material science. It collapses those painfully long design, make, test, analyze cycles. If AI can cut that process from months of manual human work down to just hours of automated iteration, it completely changes the economics of innovation.
Okay, now let's talk about robotics and embodied AI. How is this different from the kind of fixed-task industrial robots we've seen in factories for decades?
The key difference is the reasoning layer. Embodied AI is focused on translating the complex instructions from a large language model into actual motor commands for a physical robot, often a humanoid or mobile robot. Old robots just followed a pre-programmed script. These new embodied agents can respond to intent and have to handle novel situations.
Which brings us right back to the friction of safety.
The safety stakes are immediate and physical. An LLM can hallucinate on a screen and write a silly email, which is harmless. A robot in a warehouse or hospital cannot hallucinate safely. If it misinterprets a command and picks up the wrong thing or miscalculates a position, you get physical damage or, worse, human injury.
Which must mean the training process is fundamentally different.
It is. The focus is heavily on sim-to-real transfer. Engineers spend most of their time training the robot's skills in these high-fidelity digital twins, perfect simulated environments, before they ever try to deploy that skill in the messy, unpredictable, real world. It requires depth knowledge of reinforcement learning, computer vision, and classic control theory. It's the highest stakes engineering there is.
And finally, in this science pillar, we have the highest barrier to entry of all, neuromorphic computing.
This is a deep, niche, but strategically vital field. It's about designing computer chips that literally mimic the structure and function of the human brain, using things like spiking neural networks.
And why do we need to do that?
Because traditional GPUs, as amazing as they are hitting a physical power wall. They're becoming too power hungry. Neuromorphic systems promise orders of magnitude energy savings.
So this is about solving the energy friction right at the silicon level.
Exactly, and that makes them crucial for edge AI applications where power is extremely limited. Think autonomous drones, remote sensors, satellites, things that need high intelligence but can't carry a huge battery pack. These roles are concentrated in government labs and the big chip makers like Intel and IBM.
An incredible convergence of disciplines. Okay, let's switch gears completely to Pillar 4, the orchestrators. The idea here is if AI is automating the generic technical work, the value shifts to the people who define the what, the why, and manage all the uncertainty that comes with it.
Yeah, we categorize this as the era where the soft skills of the past strategy, communication, design become the new hard skills of the AI economy.
Starting with the AI product manager, or AI PM. The sources say this job is totally different from a traditional PM. What's the core distinction?
It all comes down to managing probability versus determinism. A traditional software feature, like a login button, is deterministic. It either works or it doesn't. An AI feature, a recommendation, a prediction, it works most of the time. It's probabilistic, there's always a margin of error.
And the AI PM's job is to manage that uncertainty.
It's their primary job. They have to define what success even looks like when a 100% guarantee is impossible. This requires totally new skills. They have to act as data pipeline stewards, designing the product to collect the clean data the model needs to improve.
And they need new metrics.
Completely new metrics. They can't just look at user retention. They have to live and breathe technical quality metrics like hallucination rate, recall, and precision, and then translate what an acceptable error rate means for the business.
And we also have to design the user experience around the fact that the AI might be wrong sometimes.
Yes, and that's where they work with the Human AI Interaction Designer, or HCI designer. They create what we call non-deterministic UX. For example, instead of the AI giving one authoritative answer, the interface might show 3 possible answers with confidence scores next to them. The whole design challenge is trust engineering.
So you're designing the interface to manage the user's relationship with this non-perfect system.
Precisely. You're designing how the system communicates its own confidence and how the user can easily steer an agent that's going off track. It's a huge field. Companies like Google and Microsoft are investing heavily here.
And finally, let's talk about Management 3.0, the manager as an orchestrator.
The manager of 2026 leads a true hybrid team, a mix of human direct reports and these highly capable AI agents or digital workers. Reports from the big consulting firms show that the skills needed to effectively prompt and manage AI agents, things like clear communication, fluid intelligence, and task decomposition, are becoming the new key indicators of leadership potential.
So the manager's value is less about supervising people and more about strategically delegating tasks to the right resource, human or machine.
That's the new mandate. The orchestrator has to be able to take a complex goal like create a market entry strategy and break it down. They assign the creative, nuanced, relationship-building parts to the human team, and they assign the data crunching, the research synthesis, the first drafts to the digital agents. It means every manager is now also a high-level technical project manager.
We've covered the 4 pillars, which define these high-momentum careers. But before we wrap up, we have to come back to that one friction that cuts across everything we've talked about: sustainability or green AI.
This is the looming energy paradox of 2026, and it's a central business liability. As we said, the exponential demand for compute is in direct conflict with corporate net zero goals. Training just one of these state-of-the-art models can use the same amount of energy as a small town for a year. That makes the energy footprint of AI a severe financial and reputational friction.
And this friction is creating a whole new category of jobs focused on environmental stewardship. What roles are we seeing emerge?
Well, we're seeing the rise of the sustainable AI lead. This is a role specifically focused on measuring and reducing the carbon intensity of a company's AI operations. They're responsible for conducting meticulous carbon audits of AI models, calculating the CO2 equivalent cost of a training run, or the ongoing inference cost of a deployed system.
So they're building environmental responsibility right into the deployment pipeline. And I assume there's a technical specialist who actually implements those mandates.
That would be the energy efficient systems architect.
Mm.
This role is very close to the inference optimization engineers we talked about, but their main PCI, their main metric is joules per token, not just dollars per token.
So energy efficiency is the primary goal.
It is. These professionals specialize in what's called frugal AI. They advocate for and implement smaller, greener models and more efficient infrastructure. They have to be the internal voice pushing back against the default tendency to just deploy the biggest, most power-hungry model because it's a tiny bit more accurate.
That sounds like it requires both deep technical skill and a lot of political skill to change corporate habits.
Okay.
Let's bring all of this together for our listener. What is the most critical strategic advice for someone looking for a long-term career in this new economy?
The sources are unanimous on this. The market is bifurcating, and it's happening aggressively. The middle of the market, generic coding, basic data analysis, manual process work, is being rapidly automated by tools like Copilot and advanced LLMs. You have to make a strategic choice to move either down the stack or up the stack.
Can you explain what that means for, say, a traditional data scientist who's feeling the heat from all the AutoML tools?
Sure, for that data scientist whose main job is training models, the competition from automated tools is intense. The advice is to move down the stack into that architects of autonomy pillar. Get into AI engineering, infrastructure, inference optimization, where you're dealing with low-level systems and hardware complexity.
Award?
Or move up the stack into the orchestration pillar. Move into strategy, AI product management, analytics engineering, where your focus is on defining business value, managing risk, and designing complex systems. You cannot stay in that comfortable middle ground.
So strategic specialization is the new job security.
It's the only job security. While the barrier to entry for basic tasks is getting lower, the barrier for these truly specialized roles, agentic AI engineering, algorithmic auditing, inference optimization, that barrier remains exceptionally high. They require this complex, hybrid mix of skills that simply cannot be automated away. That's where the sustainable career momentum is.
This has been a really rigorous deep dive into the reality of 2026. We started with the Great Reckoning, recognizing that the hype has been filtered out, and the economy is now built on these demands for resilience, efficiency, and real demonstrable value.
And the high momentum jobs of the next decade are all focused squarely on that. Architectural complexity, regulatory compliance, physical integration, and mastering the management of these probabilistic systems. Whether you become an architect optimizing cost or a guardian mitigating legal risk, you're solving a high-value friction that automation can't touch.
Which leads us to that final strategic imperative we saw across all our sources. Do not aim for the commoditized middle ground. You have to specialize in the frictions of AI, the cost, the risk, the physical difficulty, or the human-agent collaboration. That's where the high-value careers of the next decade are going to be found.
And that leaves us with one final thought for you to reflect on as you chart your own path. The data shows that the jobs being created, 170 million of them, vastly outweigh the jobs being displaced. But the titles and the skills are fundamentally unrecognizable. So, if the manager of 2026 has to be skilled enough to prompt and orchestrate their team of digital workers, what does that mean for how you structure your own learning and communication today to become that efficient orchestrator?
The reckoning of 2026 isn't a crash. It's a rigorous, high-stakes filter. And knowing exactly what that filter is looking for is the key to being well-informed.